Hello, everybody. In this lecture, I'm going to be talking about a variation of the t-tests, and this is the paired sample t-test. So we have three different types of t-tests, as I would have noted before. We have the independent samples t-test, we also have the paired samples t-test, and we have also the one sample t-test. I will be discussing all three, but this particular lecture is focused on the paired sample t-test. So the paired sample t-test is just another version of the t-test that is used when you want to compare two values for the same person. So the person has to be the same. And it's normally most used in conjunction with experiments. So if you think about it, when we do an experiment, especially if we were to do a pre-test and post-test control group design, then you would have to take a measure of the dependent variable prior to administering an intervention, and then taking a measure of the dependent variable after. And so the paired sample t-test allows you to compare the pre and post numbers and then try to ascertain whether or not there is a significant difference between those two. So the paired samples t-test is really called a paired samples t-test because it matches scores for each person and then determines overall whether or not there's a significant difference between the two scores. And so this is really focusing on trying to provide statistical evidence that the mean difference between paired observations on a particular outcome is significantly different than zero. And this would be considered a parametric test, right? And so we would need some kind of continuous variable to be able to calculate the t-value. So the paired samples t-test is also known as a dependent t-test, the paired test, the repeated measures test. And so, as I mentioned just now, the variable that you use in this test is known as a dependent variable or test variable, which is normally a continuous variable, and it's normally measured at two different times, or you use two related conditions or units. So, for example, you could actually do a comparison to see if a student's math scores are similar or different, significantly similar or different than their English scores, or you could look at reading versus writing, for example. So you can use related conditions or units. It doesn't necessarily have to be a pre and post, right? So you can test the significance of the difference between the two means for two different questions answered by the same respondent using the same scale. So once it is scaled the same way, then you can definitely use that. Pair samples test for differences between two means, like I said. And once the scale format is the same and the respondent is the same, then you can check to see if the differences are significant. So in terms of common usage, the paired samples test is commonly used to test statistical differences between two time points, two conditions, two measurements, or a matched pair. So again, whether you're comparing conditions, you're on the same person, or you can even compare similar things, so matched pairs. So for example, we talk about math and English, or reading and writing, or oral and written communication, for example. It can only be used to compare two related units on a continuous outcome, and we make some assumptions like normal distribution. We don't do a paired samples t-test on unpaired data, on comparisons between more than two units or subgroups, or if you have a continuous dependent variable that is not normally distributed, we would have to use a non-parametric test for that. And we also do not use it on ordinal or ranked dependent variables. That also requires a different test. So these are some of the data requirements for the paired sample t-test. Number one, your dependent variable must be continuous, which means it has to be measured at either the interval or the ratio level, right? And if you are dealing with paired measurements, they must be recorded in two separate variables. So time 1 and time 2 have to be two separate variables, or variable x and variable y have to be two separate variables. Also, you would have to have dependent observations, meaning the samples or groups for variable 1 and variable 2 have to be related. So the subjects in each sample or group have to be the same. So that means the subjects in the first group are also in the second group, because again, you are comparing two values, but for the same individual or unit, right? You want also to get a random sample of data, because again, we've talked about this in terms of generalizability. Normal distribution is another condition, and also the absence of outliers. So this speaks to the importance of a normal distribution, checking to ensure that you don't have any extraneous variables or responses in there that could affect the shape of your distribution, because that will also impact the paired samples t-test, right? You note here that in terms of testing assumptions related to normality and outliers, you can use a variable that represents the difference between the paired values, but you don't necessarily have to use, and you should not use, those paired values, right? And if the assumptions are not met, especially if you're looking at multiple assumptions not being met, then you probably want to go ahead and use a different test, like a non-parametric test, right? So in terms of what hypotheses we're testing, the hypothesis that we test is that and normally, please note that what we truly test in research is the null hypothesis, even though we normally write the alternate hypothesis. So H0 is the null, the H1 is the alternate hypothesis. And what we try to do when we are doing the statistical tests is to reject the null hypothesis. So for example, if it is that we say that we have administered an intervention and we are testing whether or not an individual scores before or after the intervention are the same, then that means that the null hypothesis is that the means are the same, the scores are the same. What we are trying to do is to reject that, to say that the intervention had an effect. So therefore, if we were to reject the null hypothesis, it means that the paired population means are not equal, right? And that's what we would like, right? So in terms of the test statistic, we use the T statistic, and it is denoted by the letter T. And if you look at the slide here, you will note that the T kind of shape weird. So it's not really the normal T. When I write it, I normally try to square off the bottom of the T to show that it's not like the regular T in the alphabet. And the T value is that is calculated. We use this formula here, which is a sample mean difference minus 0, and you divide that by the estimated standard error. And of course, as you can see, this is the standard error is going to be the sample standard deviation of the differences divided by the square root of the sample size. All right, so sample is the formula is fairly simple, but of course, luckily for us, the software does calculate this for us. In terms of our data setup, you do need two continuous numeric variables that are represented in columns that will be used, and the two variables should represent the paired variables for each subject. So each person is in a row, and we would have covered that in my tutorial videos regarding SPSS. If your data is arranged differently, then you need to restructure that to ensure that you have your two variables, right? And each subject is in a row. And if you go to the data view, normally you would see that each subject is in a row and each variable is in the columns. If you were to set up an Excel spreadsheet to import into SPSS or PSPP, then that's what you would do. You would actually put the responses in columns based on the variables, right? So this is a screenshot of the SPSS menu that you would use. So you would go to compare means, paired samples t-test. You would select your variable 1 and variable 2, right? But unlike what this is saying, I say click paste so that you paste it to your syntax and then you run it from the syntax. This is a sample of what the output would look like. So this is, we're using two questions from the same person. So you look at, and they're looking at whether or not there is a relationship between how the persons respond in terms of their level of concern about global warming and their responses about whether gasoline emissions contribute to global warming. So is there a relationship between, or did they answer those two questions similarly? And this is what is being tested here. So you notice here that they have looked at the mean difference, and now they have calculated a t-statistic, which is 8.6. The degrees of freedom is 999, and the degree of freedom here is n minus 1, because it's one pair. So you see here n is the total, but the degrees of freedom is 999. So df is actually n minus 1 in this case because you only have one pair. All right. Look, if you see here, based on our discussions, as I said before, anything that is significant has to be less than 0.05. We see here that sig is 0.000, which is lower than 0.05. So we can say here that the hypothesis here would be that the means are equal. We see a significance here, which would indicate that there is actually a significant difference between the two means, right? I think this is just a duplicate of the previous slide. So just to clarify, as I said before, you do have two tests. You have actually three tests: the independent samples t-test, the paired samples t-test, and the one sample t-test. Now, in determining which test to use, if you are comparing unpaired means between two groups on a continuous outcome variable that is normally distributed, then you choose an independent samples t-test. And because you're comparing groups, then you would actually have where the grouping variable is actually a nominal variable, but the outcome variable or dependent variable is a continuous variable. If you are comparing unpaired means between more than two groups, then you need a one-way ANOVA, and the one-way ANOVA is actually, I have done a video on the one-way ANOVA. If you are comparing means for continuous data that are not normally distributed, then you wouldn't be able to use the one sample t-test because that is for parametric data. The Wilcoxon ranks test is a good one for non-parametric data. And if you're comparing paired means or rank data, again, you want to choose a non-parametric test. So the paired samples t-test is fairly simple. I will also do a tutorial on how to actually conduct this analysis in SPSS or PSPP. And so again, I'll be happy to answer any questions that you have in our live classes. And feel free to, again, just run through the procedure as well, not just watch this video, because that's going to help solidify those concepts in your mind.